Section 6.3.11. The number of hits to a website follows a Poisson process. Hits occur at the rate of 0.8 per minute between 7 p.m. and 9 p.m. Given below are three scenarios for the number of hits to the website. We're going to compute the probability of each scenario between 7:11 p.m. and 7:21 p.m. and then we're going to interpret each result. So in this case here, we want to figure out exactly 3. Okay, now using the Poisson probability distribution function to compute the probability. Now if x is the number of successes in an interval of fixed length t, then the Poisson probability of obtaining x successes in the interval is the probability of x, which is equal to lambda times t to the exponent of x divided by x factorial times e to the power of negative lambda times t, where lambda represents the average number of occurrences of the event in some interval of length 1, and t represents the length of the interval being examined. Now, since lambda represents the average number of occurrences of the event in some interval of length 1, it is often called a rate. The value of lambda is 0.8 hits per minute. Identify the value of t. The length of the interval being examined, t, is calculated by subtracting the start time of the interval being examined from the ending time of the interval. So t is going to equal 7:21 p.m. minus 7:11 p.m., which is equal to 10 minutes. And now we're going to substitute those values for lambda. Let me go ahead and put that in here. Okay, t and x into the equation, and then calculate the value of, in this case here, since it's exactly 3, that means we're finding the probability of exactly 3. And then we're going to round that to 4 decimal places. Okay, so we're going to use this formula here. Okay, so using that formula, we know that we have the probability of 3. Okay, and what is the information that we know? Well, we know that the value of lambda is equal to 0.8. We know the value of t is equal to 10 minutes. So that means we're going to take 0.8 and then we're going to multiply that by 10 and then raise that to the power of 3, and then we're going to divide that by the value of x, which is 3 factorial, and then we're going to multiply that by e to the power of negative 0.8 times 10. And then we're going to round that to 4 decimal places. So let's go ahead and do that in our calculator. Okay, so we have 0.8 times 10, and then we're going to raise that to the 3rd power, and then we're going to divide that by 3. Let's go to factorial, so we'll go to probability, put in factorial, and then we're going to multiply that by second e here, and that's going to be negative 0.8 times 10. And rounding that to 4 decimal places is 0.0286. So 0.0286. Thus, the probability that the number of hits to the website between 7:11 p.m. and 7:21 p.m. is exactly 3 is approximately 0.0286. This means that on about 3 of every 100 such intervals, the website will receive exactly 3 hits. Okay, next, it says fewer than 3. So the probability of the number of occurrences, x, being less than a certain value, n, is the sum of the probabilities of all occurrences value less than n. So we have the probability of x is less than n is equal to the probability of x p of 0 plus p of 1 plus p of 2 all the way to p of n minus 1. We want to calculate the probability of less than 3 occurrences by calculating the sum of the probabilities of all occurrences, values that are less than the value of 3. So what we want to do is we want to find the probability of x being less than 3 is going to equal the probability of 0 plus the probability of 1 plus the probability of 2. So if we want to find the probability of 0, again, we know that lambda is equal to 0.8. We know that t is equal to 10, and then x is going to equal 0. So we have the probability of 0, which is going to equal 0.8 times 10 to the 0 over 0 factorial times e to the power of negative 0.8 times 10. Okay, so doing that on our calculator, rounding it to 3 decimal places gives us 0.000335. And so you can do the same thing you did at the top for the calculator. For number 3, we're going to find p of 1, or instead of that calling that number 3, we'll just say p of 1. So that's going to be 0.8 times 10 to the power of 1 over 1 factorial times e to the negative 0.8 times 10, which gives us 0.002684. And then we want to find the probability of 2. So that's going to be 0.8 times 10 to the second power over 2 factorial times e to the negative 0.8 times 10, which run into 3 decimal places gives us 0.010735. Okay, and so again here, what we want to do is we want to find the probability of x being less than 3, and we know that's p of 0 plus p of 1 plus p of 2. So we have 0.000335 plus 0.002684 plus 0.010735, which when we add up together and round it to 4 decimal places gives us 0.0138. So thus the probability that the number of hits to the website between 7:11 p.m. and 7:21 p.m. is fewer than 3 is approximately 0.0138. This means that on about 1 of every 100 such intervals, the website will receive fewer than 3 hits. Okay, so next it says at least 3. So what we're going to do is we're going to use the complement rule to obtain the value for an at least probability for a Poisson process. That means we're using p of x is greater than or equal to n is equal to 1 minus p of x is less than n. So that means that what we're doing is we want to find p of x being greater than or equal to 3, which is at least 3, which is equal to 1 minus the probability of x being less than 3. Well, we found that in the previous example, so we want to find 1 minus 0.0138, which gives us 0.9862. And thus, the probability that a number of hits to the website between 7:11 p.m. and 7:21 p.m. is at least 3 is approximately 0.9862. This means that on about 99 of every 100 such intervals, the website will receive at least 3 hits.